Assalamualaikum and good day everyone. So in this video, we are going to discuss on how to use product rule. So before we can solve any of this example, so let's us take a look at this one. Why we need to use product rule and when to use it. Okay, so we basically use product rule when you cannot differentiate that function directly. So when to use product rule? When you have a combination or a multiplication of two functions. Okay, so that two function can either be polynomial function with polynomial function. Okay, so the second one is the multiplication between polynomial function with exponential function, or you might have polynomial with trigonometric function. And the last one, exponential function with trigonometric function. So if you come across with any multiplication of these two functions, then you need to apply product rule to solve that differentiation problem, because you cannot differentiate that function directly. So steps to solve product rule by using product rule is, for the first one, you need to identify variable u and v. Okay, you need to identify two variables u and v. So you can choose any function to be u and any function to be v, either one. Okay, so the second step, you need to differentiate u and v correspondingly. Okay, so you need to differentiate u with respect to dx, you need to differentiate v with respect to dx. Then you can find your y prime by using uv prime plus v u prime. Let's try to solve this problem by using product rule. Okay, so as you can see here in this problem, we have a multiplication of two functions, which is between polynomial and polynomial. Okay, so my first step is I need to identify what is my u and my v. So my u, so I let my u is equals to 1 plus x. And v is equals to 25 minus x squared to the power of half. So I just change the way I write this square root. So I write it in terms of power half. Okay, so the next step is I need to differentiate u and v correspondingly. So my du dx is equals to 1. And my dv dx is equals to, so to differentiate this one, I am applying power function. So power to the front here, and we copy back what you have here. Then power, you need to minus 1, and you need to differentiate with this one. Okay, so therefore, you will have 1 over 2. So copy back this one, 25 minus x squared. So 1 over 2 minus 1 will give you negative half. And the next one is to differentiate this function. So therefore, you need to multiply with negative 2x. So simplify this one will give you negative x over square root 25 minus x squared. So by applying the product rule formula, so your dy dx or your y prime is equals to uv prime plus v u prime. So your y prime is equals to, so your u is equals to 1 plus x. Your v prime, which is dv dx, is equals to negative x over square root 25 minus x squared plus v is equals to square root 25 minus x squared, and your du dx is equals to 1. So to simplify this one, so as you can see, for this part, you have a denominator which is square root 25 minus x squared. But for this one, you have over 1. Okay, so we need to multiply this function with square root 25 minus x squared over square root 25 minus x squared. Okay, so therefore you will have, so your y prime is equals to, so as for this part, you just expand here. So you will have negative x minus x squared over square root 25 minus x squared plus square root 25 minus x squared. So we need to multiply by square root 25 minus x squared over square root 25 minus x squared. Okay, so simplify this one will give you negative x minus x squared plus, so as for this part, square root multiplied by square root. So square root here means 1 over 2. So power square root here means 1 over 2. So when you have a multiplication, power we need to add. So 1 over 2 plus 1 over 2 will give you 1. So therefore you will have 25 minus x squared. So the whole thing over square root 25 minus x squared. So simplify this one will give you negative 2x squared minus x plus 25 over square root 25 minus x squared. Okay, so this is the answer. So I shall see you in my next video for more examples. Thank you. Bye.